What is dynamic routing? Dynamic routing is when routers automatically learn and choose the best path to reach a destination. Unlike static routing, where you manually configure each route, dynamic routing updates itself whenever there's a change or failure in the network. This makes it especially useful for larger or more complex networks where manual updates would be time-consuming and error-prone. Dynamic routing and static routing differ in several ways. Dynamic routing is great for scalability. You can add more routers with minimal configuration, and the routing table updates automatically when the network changes. No manual work required. The trade-off is that dynamic routing is more resource intensive, since it consumes more CPU and memory. It also uses higher administrative distances than static routes, meaning it's not always the first choice if both are available. On the other hand, static routing shines in smaller networks. It gives you full control, is simple, reliable, and places very little demand on your hardware. Static routes also have a lower administrative distance, so they take priority by default. But the downside is, if something breaks, you'll need to manually update the routing table. So when should you use dynamic routing? Dynamic routing really shines in larger, more complex networks where managing static routes would take too much time and effort. One of the biggest advantages is automatic updates. The routers share information and update their routing tables on their own, so you don't have to constantly configure them manually. It's also highly scalable. If you add a new router into the network, you only have to configure that router, and the rest of the network learns about it automatically. This saves time, reduces human error, and makes managing growth much easier. So what is administrative distance? Administrative distance, or AD, is how a router decides which route it can trust the most when multiple routes to the same destination exist. The rule is simple. The lower the AD, the more trustworthy the route. By default, each type of route has a set value. Directly connected routes have an AD of 0, the most reliable. Static routes are 1, which makes them heavily preferred. Dynamic protocols vary. EIGRP is 90, OSPF is 110, and RIP is 120. It's important to know these values because they tell you which route your router would choose if there are multiple paths available. There are several types of dynamic routing protocols, and each works a little differently. OSPF opens shortest path first. A lead state protocol that chooses the best path based on the lowest cost. Great for large, scalable networks. ISIS, intermediate system to intermediate system. Also a link state protocol, very efficient and commonly used in large service provider networks. RIP, routing information protocol, a distance vector protocol, the easiest to configure, but limited because it only looks at hop count and doesn't scale well. EIGRP, enhanced interior gateway routing protocol, a distant vector protocol with link state features, often called a hybrid. It's Cisco protocol, efficient and powerful. What are metrics and why do they matter? Metrics are values that routers use to decide the best path when multiple routes exist. Think of them like a scorecard. The lower the score, the better the path. Different routing protocols uses different scoring systems. OSPF, cost, based on bandwidth. ISIS, cost as well, but calculated differently. RIP, hop count, how many routers you must pass through. EIGRP, bandwidth and delay, making it more precise. Metrics matter because they let routers choose the fastest, most efficient, or most reliable path instead of just sending traffic randomly. How is the path selected in dynamic routing? OSPF and ISIS both are link state protocols that select the path with the lowest cost. RIP, a distance vector protocol that chooses the path with the fewest hops to the destination. EIGRP, a hybrid protocol that uses a composite metric based on bandwidth and delay, making its decisions more accurate than RIP. Now that you have a solid foundation of dynamic routing, we'll dive deeper into each protocol individually in upcoming videos. By the end, you'll know exactly how OSPF, EIGRP, RIP, and others work, and when to use them in real networks.